breaking news from Channel 8.
Come on. Scott Sterling.
What is it?
Scott, you had a tremendous game against North Carolina, and we've received reports that soccer teams from all around the globe are looking to draft you. What is your comment on that? What are your thoughts?
All right, what? How dare you? This man has disgusting soup for a face, and you expect him to give you an interview right now? Huh? No mirrors. Hear yourself.
But fans everywhere want to know, is Scott Sterling returning to the field? Will he play again?
You know, will global warming kill us all? Will taxes ever go down? Will my mom ever hug me? No one knows, but it doesn't look good.
Scott, your fans are clamoring to buy your jersey.
You know, his jersey's not for sale, okay? No! What is it? Get rid of this box right now, okay? Just leave him be, okay? He's got road killing for a face. Come on. Where are you getting all these mirrors?
Scott,
Ma'am,
Scott,
I need you out of
we
here.
just have a few more
No,
questions.
I need you
Scott,
out
will
of
you
here.
play
I
for
will not
Best
have
How
you.
much do we
Get
have?
out. Get out.
How much are your tickets going for on eBay? Hey, look in there.
Thank you. I'm a big Scott Sterling fan. You think you might sign him a soccer ball? I don't know. Okay, I'll do it. Thanks, Scott. I'm sorry it slipped.
Wait, over here. We just received word from our news station that the LA Galaxy wants to make Scott an offer. We'll give you updates as this story unfolds.
Oh, sorry it slipped again.
Alright guys, I know you were worried about what happened to Scott Sterling, so just want to give you the update. Alright, so here we go. This is our last section of Chapter 8, Solving Exponential and Logarithmic Equations. Okay, so we're going to take it one last step further, okay? So let's start with our key questions. Daily questions. What steps should we be taking to solve an exponential and logarithmic functions? We're just doing like we did before. Okay, x. And you can say 4 to the x power equals 1 over 16. So what power do I have to raise 4 to get it to flip and then turn to 16? Well, negative to flip and then to the second power to turn to 16. Okay? 2 to the x equals 16. 2 raised to what power gives me 16? That's simply going to be 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. Lastly, negative 3 raised to the x power equals 3. Can I raise a negative number to a power to turn it positive? Yeah, I can square it, but it's not going to help me here. So this one does not exist, no solution. Okay? Very, very good. Alright, so now we can take a look at some basic properties. There are two basic strategies for solving exponential or logarithmic functions. Our first is the one-to-one properties, okay? So the first one is a to the x equals a to the y if and only if x equals y, right? This makes sense. Two things are going to be equal only if, like if they're the same base, they have to be raised to the same exponent, okay? And over here, log base ax equals log base ay if and only if x equals y. Again, this is kind of the common sense one. If they're the same base log, then you have to have the same number here in order for them to be equal. The inverse operations are a little more tricky. Once you see them in action, they'll make more sense, but please copy these down. You can do a raised to the power of log base ax, and that will equal x. Notice that if you're raising something to the power and it's the same base for the log and for this, they cancel out. This is a huge one. Okay, you'll see this a lot. And then lastly, log base a of a raised to the x equals x. If you see a log base a and then also the a right here, this almost cancels out. Remember our property, you pull your x out front. This equals 1, so therefore x equals x. Okay? So let's take a look at some of these in action. Okay, if you need to see those properties, just feel free to pause the video there. Here, 2 to the x equals 32 raised to the x minus 4. I want to get the same base so that I can use this property. Okay? So 2 to the x, that's good, 2 to the x. Can I rewrite 32 so that's 2 raised to a power? Hopefully you guys are cool with 32 being 2 raised to the 5th power. And then I have the x minus 4 up here. Okay? Same base, right? So what do I do with the exponents? Just set them equal. So I can go ahead and distribute this in. X equals 5x minus 20. I can add 20 over, subtract x. 20 equals 4x. Divide x equals 5. You can very quickly just check yourself. 2 to the 5th power is 32. 32 raised to the 5 minus 4th power is 32 raised to the 1st power. It works. Okay? Awesome. These are the easiest problems on the planet. Pardon me for that. I can add natural log of 27 over, and I get natural log of 3x equals natural log of 27. Well, guys, don't overthink this. They're both natural logs, right? Therefore, these both have to equal each other. 3x has to equal 27, divide by 3, x has to equal 9. And it makes sense. Natural log of 3 times 9 is 27. It'll equal 0. Okay? Here's your first glimpse of using your properties to your advantage. I have e to the x equals 7. Much like we talked about before, if you had something squared, the opposite is square rooting it. Okay, now here I have e to the x. I want to get rid of that. You are allowed to take the logarithm of both sides. Okay, now when I do this, I want to pick a log that has the same base as whatever's being raised to this power. So I'm going to take the natural log of both sides. Okay, natural log left, natural log right. Now we spent the last few days, this pops out front and we get x natural log of e equals natural log of 7. I want to show you guys something real quick. Here's my calculator. Natural log of e. If I put that in my calculator, I get 1. This cancels out. Therefore, my answer is x equals natural log of 7. Okay. I would accept that answer if you want to give me this answer as well. 1.95. Okay. I actually think I'd prefer this one right here, the natural log of 7. We're going to show this later on, like I'll show you when you're going to use the decimal one. Okay? So here, this is log 10 equals negative 1. Guys, what's the base here? If you don't see a number, it's got to be 10. Okay? So what you could do is, you can do 10 raised to the log x equals 10 raised to negative 1. You can raise both sides like 10 raised to those sides. Okay? What happens is 10 raised to log base 10, these cancel out and I get just x. And over here, 10 raised to negative 1 power is 1 over 10. If that seemed really confusing to you, there is another way you can do this, and I recommend trying it. Here's your base, right? Remember how we talked about rewriting it? Base of your log raised to this power equals this. So you can just do 10 raised to negative 1 equals x, and just kind of bypass that step. Either way, you end up getting 1 over 10. I don't care how you do it. You get the right answer, then you did it correctly. Okay? Awesome. On to the back. Okay? So here, we have strategies for solving exponential and logarithmic equations. Our first step is to make both sides of the equation have the same base. This is the easiest route. That one we did earlier where we raised 2 to the 5th power, it's always the easiest route. Secondly, take log or natural log of both sides of the equation. Both sides of the equation. Okay? That's just a flub up there. And lastly, exponentiate both sides of the equation. Okay, so those are your 3 steps. Easiest to hardest. This is the easiest, second easiest, and then third easiest. See how I said that? Okay, so here we go. Example number 2, solve and check the following. Can I rewrite 72 so that it has a base 4? No. Okay, so moving on. I'm going to take the log or the natural log of both sides. Okay. So in this case, I'm going to take the log of 4 to the x equals log 72. What can I do with that x? Pop it out front. So I get x log 4 equals log 72. To get x by itself, just divide both sides by log 4. So x equals log 72 divided by log 4. Okay, calculator work. Log 72 divided by log 4. I get x equals 3.08. Okay, x equals 3.08. Alrighty. You could do natural log there. I just picked log because why not? So, part B. I need to get this something raised to the x power by itself. Divide by 3, divide by 3. 2 to the x equals, this goes in 14 times. Can I rewrite 14 so that's 2 raised to a power? No. Alright, this time I'm going to take the natural log of both sides. It will work either way. I wanted to show you one example of both. I can pull this x out front, same property. X times natural log of 2 equals natural log of 14. Divide both sides by natural log of 2. X equals natural log of 14 divided by natural log of 2. Take a look at what this looks like. Okay, I'm doing natural log of 14, close the parentheses, divided by natural log of 2, close the parentheses, 3.81. Okay, awesome. Dos mas. E to the x plus 5 equals 60. Get e to the x by itself. E to the x equals 55. I just subtracted 5 from both sides. We get lucky here because if I had to choose between log and natural log, I'm picking natural log every time. Why? When this x pops out front, I have x natural log of e equals natural log of 55. What happens to natural log of e? Ooh, it turns into 1. Good stuff. So x equals natural log of 55. So I can just go ahead and use my calculator. Natural log, 55, 4.01. Okay. Again, quick little refresher. Natural log button is next to the 4. Log button is next to the 7. But here it was beneficial for me to pick natural log because it cancels out. Would you still have gotten the correct answer? Yes, but you had to hit more buttons in the calculator and we want to make our lives easier. Part D, okay, I need to get this by itself. So let's add the 4 over. I get 15. Divide by 2. I get 7.5. And now you pick log or natural log. Natural log. Again, one less letter. This can go out front. Okay. Divide both sides by natural log of 3. 2x minus 5 equals natural log of 7.5 divided by natural log of 3. I'm going to keep that in parentheses right now. I'm going to add 5 over. And I'm going to divide the entire thing by 2. So bear with me for 1 second. Everything divided by 2. Now you're probably wondering, like, why the heck am I making it look this ugly? Well, here's the deal. I want to have the most exact answer as possible. So the first part is natural log of 7.5, close it, divided by natural log of 3. Okay. If I hit enter, I get this. That's equal to 1.83. If you would have done this earlier in the problem, you would have had to round it because you would have wrote down all 10 decimal places. So I'm waiting until now so I get the most exact answer. Add 5 to it. So my top numerator is equal to 6.834043767. Divide that by 2. So my final answer is 3.42. Okay. So that's a lot of calculator work, but again, all I did there was I just waited until the end to get this. I'm going to ask that you guys go to 2 decimal places for your decimals. Okay, so go to the hundredths. But again, it's 3 basic ideas. Just to show my ugly handwriting one more time. Make both sides of the equation have the same base. Take log or natural log of both sides. If it's base 10, you want to do log for sure. If it's base E, you want to do natural log for sure. If it's neither of those bases, pick whatever you want. Okay. Or lastly, you can exponentiate both sides. So that wraps up chapter 8. We're going to get plenty of practice with this. Okay, so we'll make sure that you guys are fully confident and comfortable with it. And as always, keep up the good work and good luck. We're all counting on you.